This video presents a new interface for virtual 3D sculpting using a physical proxy. Conventionally, artists transform an idea into rough prototypes by sculpting a physical medium such as clay. The most attractive feature of clay is its hands-on interface. Similar to a sculptor's workbench, our system allows the direct manipulation of virtual models using finger gestures, tools, and a physical, deformable prop. Our goal is to explore the design space of direct finger and prop-based interaction that has the modeless fluidity of physical modeling while retaining the benefits of the digital form. Our system has been built using a commercial Vicon optical motion capture system. Passive, wireless markers attached to fingers and the prop are tracked in real time. Interaction is modelessly inferred from finger motions on, into, and around the prop to sculpt virtual models. We augment our workbench with on-prop buttons, on-table buttons, and other tools to achieve good geometric control and construction history. On the prop, the left button starts and completes operations, the middle one changes discrete parameters, and the right two change continuous parameters. A user's fingers are displayed as spheres in the work area. A transparent prop widget moves and rotates with the physical prop. We can scale the prop widget using the right buttons on the prop. The virtual model is rotated in 3D by moving the index finger on the table, similar to rotating a potter's wheel. Additional operations are invoked from a marking menu activated by a clapping gesture. Sculpting operations are often categorized as global or local. In our system, these naturally map to operations controlled by the prop or by the fingers. The prop is used to deform the region of the virtual model selected within the prop widget. Grabbing the prop engages a deformation. We support 4 example types of nonlinear deformations: tapering and flaring, twisting, bending, and stretching. These deformations can be applied simultaneously. Clicking the table button cancels the last operation. We can iteratively select other regions and deform them in a similar way. Local modeling operations are achieved by fingers and other tools. Touching and rubbing the finger on the prop smooths the model. The region of influence is indicated by the sphere at tip of the finger projected onto the model. The orientation of the fingertip to the prop can modulessly turn the entire finger into a tool. Gouging is activated by pressing into the prop. The harder the pressure, the deeper the groove. A pressure widget displays the weight factor. Gentle pressure on the top implicitly switches from gouging to smoothing. The prop widget can be locked for more precise local deformations. Similar to smoothing, the model may be also gouged using the entire finger. The prop buttons provide continuous control over the deformation radius and material properties of the virtual model. The thumb and index finger working together form a powerful compound tool for pinching and pulling clay. The fingertips control the diameter of a selection sphere that defines the region of the model to be extruded. We provide 2 types of extrusion. The first is constrained extrusion, which occurs along a straight line from the selected region to the moving fingers. The end can be rotated and scaled. When the displacement is close to a major axis, the extrusion snaps to it. The second is unconstrained extrusion, where the fingers sweep out a path achieving translation, rotation, and scaling in one continuous motion. We now look at techniques that alter the topology of the model. Here, a drilling cylinder is defined by the index finger. The radius is adjustable. Touching the prop drills through the virtual model. 3 drilled cylinders are grouped together for later use. Our system allows cut and paste operations. Pasting merges multiple models into a single cohesive model. A transparent sphere indicates the pasting point. We now view the pasted result through a cutting operation. A cutting plane is defined by 3 markers attached to a knife. Cutting the knife into the prop creates a boundary on the model. Touching the desired part keeps it. We now demonstrate all these techniques working together in 2 modeling examples. The system is presented as a compelling approach to conceptual design that combines the advantages of digital modeling with the attractive interface of physical sculpting.